Hello and welcome. My name is Vusumuzi Chawang, and I'll be showing you how to create a disqualified scenario in Proteus. So I have with me here PIC 16F7H3, and to port here I have red LEDs connected to pins A0 to A5. A4 is not connected. And then I have to port B, green LEDs connected to pins RP0 up to RP3, and yellow LED is connected to pins RP4 up to RP7. So let me just write it up. I've already written the code, so let me just show you what it basically does. So then I'll be going through the writing of the code and the compilation again. So now here's the code. Okay, this is not the code. So anyway, let me delete this project and create a new one. Select edit source code. So and then you have to select your PIC 16 and PIC 16F873, and then choose the Proteus compiler and select create quick start files to make your life a lot easier. And save this thing. Okay, then you have to open it again. Edit source code. Okay. So now I'm ready to type my code. So I'm just going to jump to start. So the first thing I'm going to do, I'm purposely going to start at this column. First thing I'm going to do is to initialize my ports using port A and port B. So I'm going to start with port A, and then port B. And then I'm going to be working with the trace registers. So let me open the data sheet for this thing. So PIC 18L72 and A73 are just the same thing, just as different pin connections. It's just the same thing. Okay. So let me go to memory organization. So the port A registers are in bank 0, and then the trace A and the AD con 1 are in banks 1. So I'll have to change my bank select, talk my bank select bit. So I'm just going to say bank select. This is an N. Just going to say bank select trace A. And then I can set my trace directions, otherwise I'm just going to clear the trace because I'm using these ports as outputs, and clear trace B. And the next thing I'm going to do is I want to set digital outputs on these ports using the AD con register. So the AD con 1 register is over here. And there it is. So to set digital output, I'll have to write a 011x or 0110, which is just a 6. I have to write a 6 to the AD con 1 register. So move later into the working register. Let me copy this. 06 and then move into the AD con register. And I'm ready to start writing my code. I've already initialized what I wanted to initialize. So I'm going to create a subroutine and call it light, which is going to be toggling, which is just going to be toggling the state of the ports to turn on and turn off the LEDs. So the first thing I'm going to do is I'm going to turn on the what? Is to turn on these LEDs. So in order to do that, I need to write ones to port A. So I've connected all these LEDs to ports RA to RA5. RA4 is not connected to anything. So I'll remove the literal. into the working register binary number. Pin 70, pin 60, pin 51, pin 40, 3, 2, 1. Into the working register. And then move from the working register to the file port A. Then I'm going to call it delay subroutine, which I'm going to create later on. Call it delay. And then clear port A to turn off the LEDs. And then now I'm going to turn on the green LEDs. So I'm going to turn on these LEDs. In order to do that, I need to write in 0F to port B. And then to turn these off and turn the yellow LEDs on, I need to write in F0. So move later into the working register 0F. And then move from the working register to the file port B. And then call it delay. And then to turn on the yellow, move the letter into the working register F0. Call it delay. And then to turn off these LEDs, I'm just going to clear port B. And then when it is done, this is going to be an endless loop, so it's just going to go back to the light subroutine. So now what I'm left with is to create the delay subroutine. So I'm going to create two variables, and I need to know where I can place my variables. So I'm going back to memory organization. So the general purpose register started is 20. I started 20. Okay. So I'm just going to create a code block starting at 20. And then code block. So I'm going to create my first variable, which I'm going to call count1, and my next variable, which I'm going to call count2. So which basically means that count1 is at address 020, then the next one is at address 021. Yeah. So what I'm going to do for the first part of the delay is move the literal into the working register FF. And then move, and then okay. And I'm going to create another subroutine and name it DL, which is going to move that into the do I need to put it in? Yeah. I don't need to create the subroutine yet. And I'm going to move this value into the register count 1. So before I go anyway, and he had set the bank select base to point to a trace, so I need to correct that and by still setting bank select port A to go back to bank 0. Okay. And then this is when I start my subroutine DL. Okay. DL. It's going to move the literal FF to count 2. And move from the file to count 2. And I'm going to create another subroutine and name it DL1. Well, what this one is going to do is going to decrement count 2 until it becomes 0. Decrement file, let's get the next instruction. If it is 0, count 2. Next instruction is going to go back to the previous instruction of decrementing. So go back, decrement the program counter by 1. And then the next thing it's going to do is decrement file and skip the next instruction if it is skip the next instruction if it is 0, count 1. And then if it is not 0, it's going to go back to DR. And when it is done, it's going to return. So this is just an ordinary glacier protein. Decrement count 2 until it becomes 0. Decrement count 1. If it's not 0, go to the end 1. Then go and repeat the decrementing of count 2, and that's how it goes. So now I'm ready to compile my code, and I know I'm going to get a lot of warnings. Okay, let's see what we have. So, okay, definitely a lot of warnings. So the first warning is what? Warning 205. So let me open the MP assembler, MP assembly user guide. If you don't have this thing, it's definitely going to struggle and stay stuck, because you never know what these error warning messages, whatever they mean. So error message 205. What does it say? A directive was found in column 1 which is reserved for labels. Okay. So what it is saying is this code block is found in a column which is reserved for labels. So I'm supposed to align it differently with the labels, just by doing this. And if I compile now, 205 is gone for the code block. So now what it is saying, 203. So now, yeah, 203 is the same as 205. So to an opcode, it's time, yeah. This one is a directive. Now it's an opcode that's found in column 1, which is reserved for labels. So the opcode is supposed to be at a different column as well. It's not supposed to be aligned with the labels. So it's definitely going to get a warning, or a warning message, so that you align your code properly and make the life easier for the compiler. That's why I started the other started the other subroutines on the correct columns, and I just started these ones on the wrong column, just to speak of this error message, because I know it's definitely going to keep a lot of people struggling. So now if I compile this thing, definitely going to get less warnings. So now the only warning I'm left with is 302. So what does 302 have to say? This is a commonly seen reminder message to tell you that a variable that is being accessed is not in bank 0. This message was added to remind you to check your code, particularly in code banks other than banks. So it's just telling you that you're working with the opcode, which register file, which is within bank 0. It's a warning message. So to turn off this error message, use the error level directive. Just the error level minus 302 to turn off the error message. So I'm just going to go up here and say error level minus 302, and the error should be gone by now, the warning message. So the only thing that I'm left, 205 first. Oh, okay, 205 for the error level, supposed to get a different column. Yeah. So the only thing I'm left with now is 305. What does 305 have to say? So 305 says, using default destination of file. If no destination is specified, okay, I didn't specify default destination. So decrement file by 1. And it's the same thing, decrement file by 1. So now if I compile this thing, it should be perfect. It should be working fine now. Okay, so now let me run the code. And it is working perfectly. Red, yellow, green. Okay, it's too slow. Let me just shift the delay a bit and put FA and compile. Red, yellow, green, red, yellow, green, red, yellow, green, and I'm done. Okay.